Good morning, ladies and gentlemen. Welcome to the third video on normals. This one involves the inverse normal distribution. Very simply, it's about trying to find what we call quantiles, and that can best be described in this little example here. A biologist wants to protect a population by only allowing the largest 5% of crabs to be harvested. He therefore wants to find what length corresponds to the 95th percentile of crabs. To answer this question, we need to find k such that x, which we assume is distributed normally, the probability that x is less than a certain number is equal to 95%. This k is known as the quantile. Alright, so basically, typical questions might look like this. Screws are produced by a machine, are normally distributed with a mean of 75 and a standard deviation of 0.1 millimeter. 1% of screws are rejected because they are too long. What is the length of the smallest screw to be rejected? So if we think about distribution here, terrible. This here is 75, and one standard deviation up is 75.1. And what we're thinking is 1% of screws are rejected because they're too long. So up here, there is some area which sums to 1% area, and anything above this value here of k is rejected. And we were asked, well, what is that value of k? And here we go to our statistics mode. So in stats, distribution, normal, inverse normal. Now here, we're asked for which way the tail goes. Here, the tail is to the right. The area is 1%, so 0.01. The standard deviation is 0.1. And the mean is 75. Execute. So this value here is 75.23, which makes sense. It is one standard deviation, two standard deviations, and a little more up. Any screw longer than that length will be rejected. Weights of an adult scallop population are known to be normally distributed. Here is another example. We're thinking, okay, so here we're given a quantile effectively and asked to find the mean. And what we can say is, well, we've got a nice diagram, and this diagram is saying that what is the probability that if the probability that x is less than or equal to 58.2 is 0.15, that is troublesome for us because we don't know how to calculate the mean for it. Instead, what we can say is, let's find the quantile associated with that for z-scores. So we can say the probability that this converted into a z-score is equal to less than 0.15, and we're going to find that normal distribution. And we're using standard normal because we know its mean and standard deviation. So if we bring up our calculator, we can say tail now left, area for 15% is 0.15, standard deviation is 1, mean is 0. Calculate. This here is minus 1.0364. There. Therefore, 58.2 take the mean divided by 5.9, which is our standard deviation, is equal to this. Basically what it's saying is that this here is 1.0364 standard deviations down from the mean. And by using a z-score, we can then calculate, well, what the mean must be using our z-score calculation, which works out to be 64.3. Alright. Another short video, but hopefully you can see how inverse normal can be extremely useful, and you know some of the terminology surrounding quantiles and how to use your calculator. Alright, thank you very much.